Good morning. Myself Sreelatha. Today I will discuss about microprocessors and microcontrollers. So in this microprocessors and microcontrollers, the topic will be I will choose a topic microprocessor control temperature system. So let us discuss the block diagram on the blocks existing, how the microprocessor works in this temperature control system. What is the main motto of this temperature control system? So let us discuss block by block, topic by topic. See, the main objective of this concept is nothing but to understand how to control the temperature. It's the main thing, to control the temperature. And the next thing is nothing but to minimize the manual hand, nothing but to overcome the manual hand and to reduce the manual intervention using by 8085 processor. And the third thing is nothing but it controls the temperature of any industrial or any some other laboratories. The main thing is nothing but it controls the temperature of any industrial plant also. These are the 3 points has to understand by using this topic. This is the block diagram. It consists of 8085 microprocessor. So along with inputs and output ports. This is nothing but system bus, nothing but a data bus. Here temperature sensor, A to D converter, and we are using memory also. That it is of 2 types, ROM and read or write memory. These are input ports, input port 1, A to B converter, temperature sensors. And here we are using output ports as a fan and heater, and also third port is nothing but LCD, liquid crystal display. So let us discuss the memory, input ports and output ports one by one. System hardware consists of microprocessor, as now we discussed earlier, microprocessor, memory, input devices and output devices. So what is temperature control? So it is a process in which change of temperature of a space. It means that the objects will collectively gather together and it is measured, or otherwise simply we can say that detected, and the passage of heat energy into or out of the space is adjusted to achieve a desired average temperature. Change of temperature of a space, whatever we changed and we collected, that has to be measured. So this is nothing but temperature control. Here, this temperature control system is a type of control system that automatically controls the temperature of an object or an area. The system sets 2 points here, upper limit point, lower limit point. So what is the usage of this upper limit point and lower limit point is nothing but this upper limit point, the system has to read the temperature on room, will read the temperature on the system, reads the temperature on room, and it will display the temperature at LCD display panel, and finally it will turn on or off the fan or heater. It totally depends upon the temperature. It totally depends upon the temperature. If the temperature, it will turn on the fan when the temperature reaches the upper limit point, and turn on the heater when temperature reaches the lower limit point. So for that purpose, it uses 2 points, upper limit point and lower limit point, when it reaches the output as a fan or a heater. See how the block diagram microprocessor, how the microprocessor will be working under this temperature control system. So here we are using 8085 microprocessor, which is 8-bit, and here we are using along with system bus is nothing but a data bus. Here what the processor will do is nothing but the processor will read the binary instructions from memory and execute those instructions continuously. Whatever the instructions, memory has to be given from memory to the microprocessor whenever it is needed. That instructions has to be read and execute those instructions continuously. And it will read the temperature and display it at the LCD panel, and see again that turn on or off the fan or heater based upon this temperature. Coming to the next slide. Here, memory. Memory consists of two types of memory: ROM, read or write. ROM is used to store the program permanently, that is responsible for providing the instructions to the processor to monitor the system. It is a permanent storage of data. It is used to permanent storage of data. And read or write is used to store the data temporarily. It means the read-write memory is needed for temporary storage of data. Here we are using two types, ROM and RAM. ROM is used for permanent, read or write is used for temporary storage of data. And here input devices. And see here, coming to the block diagram here, input devices. Temperature sensor is nothing but acts as the input device here. Temperature sensor is nothing but a input device. This input device acts as a transducer, which converts from one form of energy into another form. The main definition of transducer is nothing but it converts one form of energy into another form. So here temperature sensor itself converts this temperature into electrical signal. So can we say some examples? Means microphone. Microphone is also one of the input device. It acts as a transducer. It converts sound signal into electrical signal. And some more thermocouple. Thermocouple also, it converts heat energy into electrical energy. So like that, this temperature sensor converts temperature into electrical signal. Simply, we can say that the electrical signal is nothing but an analog signal. So temperature is an analog signal converted into digital. How it can be converted into digital means with the help of A to D converter, analog to digital converter. This analog to digital converter converts this analog signal or electrical signal in the form of binary, in the form of binary bits, that is nothing but a digital signal. We call that as a digital signal. How we can read this data, this digital data? So for this A to D converter needed microprocessor to read this digital signal from input port. To read this digital signal from input port. For that purpose, we use this analog to digital converter. And next, output devices. Here output devices are fan, heater, LCD. When the fan will work, when the heater will on, and well, what is the purpose of LCD? Let us discuss here. Fan is nothing but, it is also one of the output device that is turned on by the processor when the temperature reaches upper limit, as we discussed earlier. It is also output device. It is turned on by the processor when the temperature reaches the upper limit. And what about heater? This is turned on by the processor when the temperature reaches lower limit. If the temperature reaches lower limit, then the heater will be turned on. Otherwise, it will be off. That will be shown in output 2. The fan will be shown in output 1. And what about this LCD? Is nothing but a liquid crystal display. Simply it displays the temperature. It is nothing but it is a display made up of crystal material placed between two plates in the form of dot matrix or 7 segments. It can display either letters, display characters, or graphical symbols. So finally, LCD is used to display the temperature purpose itself. Some examples will be there. Let us discuss that examples. This is the room temperature controller. The temperature will be observed in room. Can be called as room temperature controller. This is one of the example. And other one is micro oven. It is also one of the example for microprocessor temperature control system. Inside we are using the processor, and we depends upon the temperature it will work. The oven will whatever the item will kept inside, that will be heat, depends upon the temperature what we are giving that time. This is one of the example microwave oven. Next, chemical labs. In chemical labs also, by seeing that, we can control the temperature in chemistry labs also. And finally, nature. In nature also, we can observe the temperature. We can find that, we can found that. So these are some examples of temperature. Read back to that block diagram. See, whatever the memory block consists of ROM or read or write memory, that has to be given to the microprocessor. This is this microprocessor fetches the instructions, reads the instructions from the memory, and given back to the from the input port. Whatever the temperature sensor from, it has to be given to the A to D converter, and finally we have to read the instructions from the read the temperature from the input port, and from that depends upon the fan or cooler on or off, or heater will on or off. That totally depends upon, and finally we will display the output at port 1 or 2. It depends upon the temperature. And here, whatever the input and output devices are connected through the ports of port of input and output ports. And finally, the output port 3 will be given to the liquid crystal display. So this is about microprocessor temperature control system. So finally exists of how the temperature will be controlled with the help of the microprocessor. Thank you.